Hello, and welcome to our video on multiplexers. Okay, we had a very recent video on decoders, but now we're going to be talking about multiplexers. The use of multiplexer is very important in data storage and data management. Say we have 4 people that want to store data. This can be 4 people, it can be 4 devices, it can be 4 registers, it can be anything. 4 places you want to take data from. Anika, Bobbert, Krish, and Moose. These 4 people want to put their data into our memory. But how do we pick which data we want to use? So, like we spoke about before, all of the wires are always connected. So we need a way to choose between any one of these 4 to have data come and go into our output, memory, anything you want to call it. How do we do that? We use a multiplexer. A multiplexer is a very, very cool tool that allows us to pick which one we want. A multiplexer has n number of inputs and it has one output always. There's always going to be one output in every multiplexer. But the one thing to remember is we have select lines. These work very similar to a decoder. In a decoder, we have our select lines, and our select lines will pick which one of these 4 we want to get. These 2 will connect to one of these 4. Now, we're doing a similar type of thing, but these select lines will pick which one we allow to pass through. If we look over here, this is what the multiplexer actually looks like on a gate level. These are our 2 select lines, and these are our 4 inputs. And these select lines will allow something to pass through. Looking at this truth table, we can see it very clearly. If our select lines are 0 and 0, then A will pass through. A here. Or we can also call that A for Anika. Select lines are 0 and 1, Bobbert or Bob or B will pass through. 1 and 0, C, Krish or C will pass through. And 1 and 1, D or Moose will pass through. That's why multiplexer is super important. So since we have all this data and only want one coming out, we use a multiplexer. So now let's talk about a very important part of multiplexers. We have select lines. These are going to be how many options. This is going to let us pick how many options you want to choose from. Say we have a ton of different inputs, hundreds, 12, 4, whatever random number. But we want to pick from one of these inputs. So a very important thing to remember, very similar to decoders, is the relationship between inputs and select lines. And always remember how many outputs? 1. Forever, always 1 output. So the way select lines work is the same as decoders. 0, 0 translates to 0. 0, 1 translates to 1. But say we want to get to number 16. If we want number 16, we have to do 1, 0, 0, 0. Sorry, we wouldn't actually get to 16. We would go 15, and 15 would be 1, 1, 1, 1. If we want 1, 1, 1, 1, we use 15. We need 4 select bits. So this n would equal to 4. If we have 4 select bits, we can do 2 to the power n, or 16 total conversions, which is from 0 to 15. Any number in between we can pick from. Very similar, you're going to get a lot of questions in the same way where you have, hey, I want 31 inputs, and I want 1 output. How many select lines do I need? Select line. How many do I need? I would need 31 is 2 to the power n. What is our n value here? Be 5. Because if we have 32 options, we can fit 31 in there. So with 5 lines, we could pick from 32 different spots. Very simple. Multiplexers allow us to pick which data we want to come in and which data we want to let through. We use select lines to figure out which one of our data will be passed through. This is what it looks like on an actual gate level. This is only using 4 inputs and 2 select lines. This can be up to as many inputs and as many select lines as we want. And this is a simple truth table for this. Depending on our select, we get a certain input. 1, 1 will give us the last input. 0, 0, 0 will give us the first input. Thank you. This is all about multiplexers.